Hello and welcome to yet another video of Cornerstones of Math. Today we are going to solve the following problem. Let fx be x squared minus x plus 1. Find the real roots of the equation fx times fx squared times fx to the power of 4 times fx to the power of 8 times fx to the power of 16 equals 2 divided by x squared plus x plus 1. So let's get started. This equation looks a bit complicated, but many basic principles of solving equations still apply to this problem. For example, we have this fraction on the right hand side, and when it comes to fractional equation, we know that we have to get rid of the fraction by multiplying the denominator on both sides. So multiplying both sides with x squared plus x plus 1 gives x squared plus x plus 1 times this equals 2. And now we have to simplify the left hand side, so let's write down everything as polynomials using the given expression for fx. So we have x squared plus x plus 1, then x squared minus x plus 1, then x to the power of 4 minus x squared plus 1, x to the power of 8 minus x to the power of 4 plus 1, and x to the power of 16 minus x to the power of 8 plus 1, and finally x to the power of 32 minus x to the power of 16 plus 1 equals 2. Here, let's focus on first two polynomials. Let's multiply them. If we consider this common part x squared plus 1 as a single variable, then this is basically in a plus b times a minus b form, which gives a squared minus b squared. So we have first x squared plus 1 squared, then minus x squared. So we have x to the power of 4 plus 2x squared plus 1 minus x squared. So we have x to the power of 4 plus x squared plus 1. And we can keep using this formula to expand and simplify the left-hand side. Notice that on the left-hand side, now we have x to the power of 4 plus x squared plus 1 times x to the power of 4 minus x squared plus 1 and the rest. So here we have the same format again, which we can apply our formula. So these two will give x to the power of 8 plus x to the power of 4 plus 1. These two will give x to the power of 16 plus x to the power of 8 plus 1. These two will give x to the power of 32 plus x to the power of 16 plus 1. So we eventually have x to the power of 64 plus x to the power of 32 plus 1. Therefore, the equation becomes x to the power of 64 plus x to the power of 32 plus 1 equals 2. Here, let's use the substitution. X to the power of 32 equals t. Then we have the equation t squared plus t plus 1 equals 2. So t squared plus t minus 1 equals 0. We are looking for real number x, and when x is real, t, which is x to the power of 32, is non-negative. Therefore, we choose the non-negative value for t, which is minus 1 plus square root of 5 over 2. This means that x to the power of 32 equals minus 1 plus square root of 5 over 2. Here, we don't have to be scared about this degree 32 because we are only looking for real roots. And there are only two real roots for an equation like this. One root can be expressed by using radical with number 32 right here. And this refers to the positive real value among 32nd roots of minus 1 plus square root of 5 over 2. The other root is simply the minus of that notation, which refers to the negative real root. So we have found two real roots, so we're done, right? Well, we are not done yet. Since the given equation is a fractional equation, we have to make sure that the obtained roots do not make the denominator 0. So let's start with positive real root. If x have this value, then x squared plus x plus 1 is obviously positive, so it is non-zero. What about negative real root? If x have this value, then we can simply let minus x, which is this value, as u. Then we use the fact that our new variable u is positive. In this case, x squared plus x plus 1 equals minus u squared plus minus u plus 1. So u squared minus u plus 1. And we can easily complete the square to obtain u minus 1/2 square plus 3/4, which is positive. Therefore, none of these two roots make denominator 0. Hence, they are all valid roots. Therefore, our final answer is this. And that's all for today's video. Thank you for watching, and I will see you in another video.